Polymorphism is the third pillar of object-oriented programming. And if you know a little bit about the Greek language, which I don't, you'd know that poly stands for many and morph stands for shape. And thus we're talking about the concept of many shapes. That's a good description for the behavior that we can achieve with C#. I can have a variable of type gradebook, and I can point to objects with different shapes, so objects with different types. As long as all those objects inherit from or are a gradebook, then it's legal. So my gradebook variable can point to a gradebook, but it can also point to a throwaway gradebook, because again, another way to think about inheritance is to think about is-a relationships. We say that a throwaway gradebook is a gradebook. It derives from gradebook. Gradebook is a base class. And anytime you have an inheritance relationship, you can have a variable typed as a base class that points to an object derived from that base class. I cannot have a variable typed as string that holds an integer value because those two types have no inheritance relationship, but I can declare a variable typed as object and point it to anything, a string, an integer, a datetime, a gradebook, because system.object is the ultimate base class for anything and everything in .NET. Everything in .NET ultimately derives from system.object. So if you declare a class and do not explicitly declare a base class for that class, the base class is system.object. Just like the code on the screen is being very explicit and saying that class A inherits from object. I could leave the colon object off and have the same result. And class B inherits from class A, which inherits from object. So an instance of B is an A and is an object. There's also a keyword in C# to work with system.object, and that's just the word object with a lowercase o. Now in this code, both class A and class B have a doWork method. And just like with the gradebooks that we're working with, we want these two methods to behave differently. Currently we have a throwaway gradebook, but we assigned that object to a gradebook variable. And when I call compute statistics, we saw that we're invoking the compute statistics method in the gradebook, not the throwaway gradebook. And that's because the C# compiler, without any other information, is going to choose the method to invoke based on the type of the variable. If I define a method or a property with a virtual keyword, then the C# compiler will generate code to invoke that method by looking at the type of object it's working against at runtime. Without the virtual keyword, the method we invoke is determined by the type of variable that we're invoking the method through. It's the virtual keyword that gives us polymorphism, because now I can have a variable that points to different objects, and when I invoke methods or properties on those objects, they can all behave differently. Classes that inherit from class A can override that doWork to behave differently. Let's get a concrete example with our gradebook. Currently in the gradebook project, we are not achieving polymorphism. We're not achieving polymorphism because compute statistics in my gradebook class does not use a virtual keyword. And thus, when the C# compiler sees a call to compute statistics through a variable typed as gradebook, the C# compiler will determine the method to call based on the type of this variable. So it sees gradebook.computeStatistics, it's going to invoke compute statistics, the one that is defined inside of gradebook.cs. But let's do a little bit of an experiment. Let's temporarily say that writeResults has to take an object of type throwaway gradebook, which means I also need to type this variable as throwaway gradebook, because writeResults will no longer accept just a gradebook. It has to have a more specific type, the throwaway gradebook. And now if I run the program, I can see I call into throwaway gradebook compute statistics, which calls into gradebook compute statistics. And now the average is up to a 90.25, which is an A. We've thrown away the lowest grade, which is what we wanted to do. But I'd like to achieve the same behavior using polymorphism. I'd like to achieve the same behavior leaving this variable typed as gradebook and having writeResults take an object that is just a gradebook. Because with the magic of polymorphism, I can implement writeResults to take a gradebook and have many different types of gradebooks and have those objects behave differently without me doing any additional work inside of writeResults or tying myself to a specific type of gradebook, like the throwaway gradebook. In fact, I'm even going to take this line of code and press Control period and tell Visual Studio that I want to extract this into a new method. I'm going to call this method create gradebook. And although it might not make a lot of sense here in a simple application like we have with the gradebook, but there are many times in software where you want the flexibility of having something created for you via a factory class or a provider or some sort of infrastructure that's in your application. You just want something to be created for you. Know that it has some type, like a gradebook type, but you don't ultimately want to know exactly what type you're working with. Is it a regular gradebook? Is it a throwaway gradebook? Really, all the rest of the code that I have inside of program.cs doesn't care. So I want to work with variables of type gradebook, but have polymorphic behavior when I invoke methods like compute statistics. And that's when I have to come into gradebook.cs and use the virtual keyword, because now when the C# compiler sees me invoke compute statistics through a variable typed as gradebook, it's no longer going to use the type of variable to figure out which method to call. Instead, it's going to use the type of object, the type that it sees at runtime. So if it sees ultimately that that gradebook is a throwaway gradebook, it will go looking to see if the throwaway gradebook overrides compute statistics. And this doesn't mean that I hide or replace the compute statistics method that is in the gradebook. I can still access that method using base.computeStatistics. It just means that if someone does invoke compute statistics, I have the ability, if we're really working with a throwaway gradebook, to change the behavior of what's going to happen. In this case, invoke my method that I've implemented for compute statistics instead of the method defined in gradebook. And just to go back and talk a bit about what was on the slide, gradebook, I haven't defined a base class for gradebook, but technically gradebook does inherit from system.object. And that's why inside of program.cs, anytime I'm using IntelliSense against gradebook, I can see methods that I haven't defined in the gradebook, methods like get hashcode, get type, toString. Those are all methods that are defined on system.object, and those are all methods that I can override. If I just type override in Visual Studio and press space, Visual Studio is smart enough to figure out which methods that I have in my inheritance chain that are virtual that I can override. So if I wanted toString to behave differently, I can override that method and provide my own custom implementation of what will happen if someone says book.toString. But now we're working with variables of type gradebook, but gradebook has a virtual method, compute statistics, and throwaway gradebook, which inherits from gradebook, is going to override that behavior. I should be able to achieve polymorphic behavior when I say book.computeStatistics. I'm not going to know exactly what happens at this point at compile time. I don't know what compute statistics will be invoked because the method that is invoked will depend on the type of object that is passed in here, not the type of variable. So Control F5, and I can see, even though I'm working with a variable of type gradebook, I am calling throwaway gradebook, and the lowest grade is an 89.5, which means the low grade has been thrown away, and the letter grade is an A.